sound card. In this video, we are going to learn about sound card. Sound card. A sound card is an expansion card or an integrated circuit that is attached to the motherboard to enable the computer to get input, process, and deliver sound. Generally, motherboard consists of the inbuilt sound card, but for more efficiency, sound cards are added separately. These built-in sound cards can be disabled in order to use a high-quality sound card which is purchased and installed separately, although the built-in device is likely adequate for those less sound quality. A sound card typically comes with a proprietary software and drivers. Through standard Microsoft operating systems automatically detect and load drivers for the popular cards. The software interfaces with the card to allow the user to set parameters and controls and to perform checks on the hardware. It might also come with tools for recording, editing, or composing. It is also called as audio card, audio adapter, sound adapter. The typical card has an interface available at the back of the computer with various input and output ports, including the speaker plug. Uses of sound card. Typical uses of sound cards include providing the audio component for multimedia applications such as music composition, editing video or audio, education,
World of Mumbai and is likely to be completed by 20 World of
entertainment, video projection. Parts of sound card. Versa jack, yellow. Line input, light blue. Line level stereo audio source such as stereo receiver, CD player, cassette deck, or VCR audio outputs. Mic input, pink. Microphone. Front speakers out, lime green. Stereo pair powered speakers. Headphone out. Stereo headphones. Joystick or MIDI connector. Components of sound card. In this video, we are going to see the components of the sound card. The main components of sound card are digital signal processor, DAC, that is digital to analog converter, ADC, that is analog to digital converter, external I/O connectors, internal I/O connectors. Digital signal processor, that is DSP. The specialized microprocessor called the DSP, digital signal processor, which does all the digital audio processing, that is echo, reverb, vibrato chorus, tremolo, 3D effects, etc. Digital to analog converter, DAC. The digital to analog converter or DAC, which converts the computer's audio data into an analog signal for being sent to a sound system, such as speakers or an amplifier. analog to digital converter ADC. The analog to digital converter or ADC, which converts an analog input signal into digital data which a computer can process. External input or output connectors. One or two standard 3.5 mm line-out jacks, normally light green in color. A line-in jack. A microphone input, sometimes called mic, usually a pink-colored 3.5 mm jack. A musical instrument digital interface MIDI connector, usually gold-colored, which is used for connecting musical instruments and can serve as a game port for plugging in a controller like a joystick or gamepad. Internal input or output connectors. A CD-ROM or DVD-ROM connector with a black socket, which is used to connect the sound card into a CD-ROM's analog audio output using a CD audio cable. Auxiliary inputs, aux-in, with white sockets used for connecting internal audio sources such as a TV tuner card. Microphones. In this video, we are going to see microphone and its types. A microphone is an acoustic to electric transducer or sensor that converts sound in the air into an electrical signal. Early microphones were invented for communication purposes. Later modifications were made to design as the microphone was used more in the entertainment industry. First, the information in the form of a sound signal is produced. Then, the signal is converted into an electrical signal by the microphone. The electrical signal is then converted to sound signal by a loudspeaker. Microphones are used in many applications such as telephones, tape recorders, karaoke systems, hearing aids, motion picture production, live and recorded audio engineering, FRS radios, and megaphones. Types of microphones: carbon microphones, dynamic microphones, ribbon microphones, condenser microphones. The carbon microphone, also known as the carbon button microphone, is a type of microphone in which a transducer converts sound to an electrical audio signal. Carbon microphone consists of two metal plates which are separated by granules of carbon. One of the plates faces outwards and acts as a diaphragm so that when sound waves strikes this plate, the pressure on the granules changes, which in turn changes the electrical resistance between the plates. A direct current is then passed from one plate to the other plate, which causes the changing resistance to result in changing current, which can be used in many ways such as being passed through a telephone system. Dynamic microphones are the standard general-purpose microphones and are versatile. A dynamic microphone takes advantages of electromagnetic effects. When a magnet passes through a wire or a coil of wire, the magnet induces current to flow in the wire. In a dynamic microphone, the diaphragm moves either a magnet or a coil when sound waves hit the diaphragm, and the movement creates a small current. This variation in the current is correlated with the sound wave as output. They have no internal amplifier and do not require batteries or external power. This created output signal is amplified and wave-shaped to get better sound output. Ribbon microphones. A ribbon microphone is a type of microphone that uses thin aluminium. Duralumin is sometimes a nanofilm ribbon which is placed in between the poles of the magnet, which in turn generates voltages by electromagnetic induction. Ribbon microphones are standard bidirectional, which means that they pick up sounds equally on opposite sides of the microphone. As the ribbon vibrates, a voltage is induced at right angles to both the ribbon velocity and magnetic field direction and is picked off by contacts at the ends of the ribbon. Ribbon microphones are also called as velocity microphones because the induced voltage is proportional to the velocity of the ribbon and thus of the air particles in the sound wave. Condenser microphones. Condenser microphone is a purely electrical system that depends upon variations in internal capacitance for its operation. Condenser or capacitor microphones uses a lightweight membrane and a fixed plate that act as opposite sides of a capacitor. Sound pressure against this thin polymer film causes it to move. This movement changes the capacitance of the circuit, creating a changing electrical output. In many aspects, a condenser microphone functions in the same manner as an electrostatic tweeter, although on a much smaller scale and in reverse. Speakers. In this video, we are going to see the concept of speaker and its working. What is a speaker? A computer speaker is a hardware device that is used to convey sound produced by a computer system. A loudspeaker or speaker is an electromechanical transducer which converts an electrical signal into sound. They are used in amplifying sound from the internal computer speakers. Computer speakers are also known as multimedia speakers. Components of speaker. The components of speaker are described as follows. Backplate pole. This part is usually made of iron or a similar permeable material to form the magnetic circuit with a magnet. The front plate and pole piece forms the gap of the magnetic circuit along with the magnet, and frame serves to dissipate heat away from the voice coil. Some drivers include ferrofluid in the gap to further cool the voice coil and provide resonance damping. Magnet, providing a stationary magnetic field to oppose the alternating electromagnetic field of the voice coil and thereby cause the attached cone to move inward and outward. Most drivers use a ring-shaped magnet that is made of a ferrous ceramic material. Top plate. The top plate from the gap of the magnetic circuit along with the magnet and frame serves to dissipate heat away from the voice coil. This is similar to backing plate pole. Coil. The voice coil is a coil of wire, usually copper or aluminium, through which the electrical audio signal flows. The flowing current of the audio signal alternates, creating an electromagnetic field which is opposed by the permanent magnetic field of the magnetic circuit. This causes the voice coil and diaphragm to move. Basket holds all of the speaker's parts together and gives them something to mount to. Additionally, the basket also offers a flange to allow the speaker to be mounted to a baffle of some kind. Spider. This is a device that centers the moving parts of the speaker. Usually made from cotton, it allows the moving parts to move in and out, but not side to side. Without a spider, the speaker's movement would be uncontrolled and it would easily destroy itself. Cone expands the area swept by the movement of the voice coil. Voice coil can be attached to many different cone sizes depending on the purpose of the speaker. The ideal cone is light, strong, and well dampened. If the cone is too heavy, it will be slow to respond to the movement of the voice coil. If the cone is weak, it will flex or bend. If the cone is not well dampened, it will color the sound with harmonics or resonances. Dust cap is a small dome or inverted dome over the middle of the cone. Underneath it lays the center of the voice coil former and the pole piece. The dust cap keeps harmful things from entering the speaker's internals and damaging them. Working of speaker. When an electric current passes through a wire coil, that is the voice coil, in a magnetic field, it produces a force which varies with the current applied. The cone connected to the voice coil moves in and out, creating waves of high and low air pressure. The coil and magnet assembly are the motor structure of the loudspeaker. The movement is controlled by the loudspeaker's suspension, which comprises the cone, surround, and the spider. The surround and spider allow the coil to move freely along the axis of the magnet's core or pole without touching the sides of the magnetic gap. Eminence technology and proprietary materials mean that age-old compromises of durability against sensitivity or power handling against the precision of response are more easily solved. Advantages of speaker. They produce sounds in response to an electrical audio signal input. They have extremely lightweight diaphragm which is driven across its whole surface. Long-lasting and pretty durable if operated within their intended power levels. Larger loudspeaker systems are used for music, sound reinforcement in theaters and concerts, and in public address systems. Disadvantages of speaker. Since their feedback must be compensated for the amplifier and easily destroyed if overpowering. They include lack of bass response, limited in frequency response, and requires multiple speakers to produce a full sound spectrum of 20 to 20,000 Hz. Magnetic tape recording. In this video, we are going to learn about magnetic tape recording. Magnetic tape. Magnetic tape is a medium for magnetic recording made of a thin magnetizable coating on a long, narrow strip of plastic film. Devices that record and playback audio and video using magnetic tape recorders and videotape recorders. Magnetic tape provides a compact, economical means of preserving and reproducing various forms of information. There are two common forms of magnetic tape: reel-to-reel magnetic tape, cartridge magnetic tape. Reel-to-reel magnetic tape. Reel-to-reel tape recording is a form of magnetic tape audio recording in which the recording medium is held on a reel rather than being securely contained within a cassette. Cartridge magnetic tape. The tape is supplied in a small cartridge rather like a music tape. This type of tape is used on PCs or microcomputers, and the device used to read or write the tapes is called a tape streamer. Working of magnetic tape recording. A plastic film tape is coated with an iron oxide coating. Perpendicular recording. Basically, this tape is passed by and in contact with a recording head that consists of a metal core with wire windings on it, essentially an electromagnet.
This electromagnet has applied to it a changing voltage that is generated by the voice or video or data that one desires to record.
The tape keeps moving, so the oxide has a magnetism imparted to its oxide coating, the strength of which is dependent upon the level of voltage applied to the head at any time any particular point of the tape passes it. The recording head consists of a core with a coil. The core has an air gap at the front side. Magnetic tape recorder consists of write head, read head, wire coil, empty bits, written bits, underlayer. When the current flows through the coil, a magnetic flux is produced in the core. At the gap, the flux will be forced out. The tape moves at constant speed while it is in close contact with the working gap of the recording head. This electrical voltage is amplified and the sound or video or data is reproduced to be the same as the information put on the tape in the first place. The storing of data is done by polarizing the magnetic tape by the head. The direction of polarizing forms different words. Advantages of magnetic tape. The cost of storing characters is very less as compared to other storage devices. Long-term storage and reusability. Copying of data is easier and fast. Disadvantages of magnetic tape. If the data is stored near a strong magnetic field or a loudspeaker, the tape can be damaged. Magnetic tape has a lifespan of 15 years. Data quality gradually erodes over time. Digital recording. In this video, we are going to see about digital recording. Digital recording is a method of preserving sound in which audio signals are transformed into a series of pulses that correspond to patterns of binary digits, that is zeros and ones, and are recorded as such on the surface of a magnetic tape or optical disc.
Process of digital recording.
Source, mic, recorder, computer, speaker. Sound waves live out in space and it is in the air around us. To edit and record the sound, we need transducers. Microphone, which is also a transducer, is used it can change the sound energy into electrical energy. After the microphone has converted those sound waves, the electrical voltages can be thought as analog. The electrical or analog signal is transformed to a computer system as digital signal for recording and editing process. The digital signal is converted into numerical values which computers can work with editing, adding effects and recording the sounds. After the work's done on the computer, the sound can be get the way out by converting digital into analog signal through the speaker cable. Now, the analog signal is converted into acoustic sound waves through the speaker. This whole process is referred to as analog to digital conversion and digital to analog conversion. Digital signal processing, that is DSP. In this video, we are going to see the block diagram of digital signal processing. Digital signal processing, that is DSP, refers to various techniques for improving the accuracy and reliability of digital communications. Digital signal processing is the mathematical manipulation of an information signal to modify or improve it in some way. The signals need to be processed so that the information that they contain can be displayed, analyzed, or converted to another type of signal that may be of use. In the real world, analog products detect signals such as sound, light, temperature, or pressure and manipulate them. Converters such as an analog to digital converter then take the real world signal and turn it into the digital format of zeros and ones. Block diagram of digital signal processing. Recording phase. Analog audio is given as input through a receiver or other source. This analog signal is then converted to a digital signal by an analog to digital converter and passed to the DSP. The DSP performs the MP3 encoding and saves the file to memory. During the playback phase, the file is taken from memory, decoded by the DSP, and then converted back to an analog signal through the digital to analog converter, so it can be output through the speaker system. In a more complex example, the DSP would perform other functions such as volume control, equalization, and user interface. If the received signal is digital, for example, computer data, then the ADC and DAC are not necessary. The DSP acts directly on the incoming signal, eliminating irregularities caused by noise and thereby minimizing the number of errors per unit time. Signal sampling. This video explains about signal sampling. With the increasing use of computers, the usage and need for digital signal processing has increased. To use an analog signal on a computer, it must be digitized with an analog to digital converter. Sampling is usually carried out in two stages: discretization and quantization. In the discretization stage, the space of signal is partitioned into equivalence classes, and quantization is carried out by replacing the signal with a representative signal of the corresponding equivalence class. In the quantization stage, the representative signal values are approximated by values from a finite set. The Nyquist-Shannon sampling theorem states that a signal can be exactly reconstructed from its samples if the sampling frequency is greater than twice the highest frequency of the signal but requires an infinite number of samples. In practice, the sampling frequency is often significantly more than twice that required by the signal's limited bandwidth. Digital signal processing domains. This video explains about the digital signal processing domains. In DSP, engineers usually study digital signals in one of the following domains: time and space domain, frequency domain, Z-plane analysis, wavelet domains. Time and space domain. The most common processing approach in the time or space domain is an enhancement of the input signal through a method called filtering. Digital filtering generally consists of some linear transformation of a number of surrounding samples around the current sample of the input or output signal. Frequency domain. The signals are converted from time or space domain to the frequency domain, usually through the Fourier transform. The Fourier transform converts the signal information to a magnitude and phase component of each frequency. Z-plane analysis. Whereas analog filters are usually analyzed in terms of transfer functions in the S-plane using Laplace transforms, digital filters are analyzed in the Z-plane in terms of Z transforms. A digital filter may be described in the Z-plane by its characteristic collection of zeros and poles. Wavelet domains. In numerical analysis and functional analysis, a discrete wavelet transform, that is DWT, is any wavelet transform for which the wavelets are discretely sampled. Applications of digital signal processing. In this video, we are going to see the applications of digital signal processing. The applications of digital signal processing are audio signal processing, audio compression, digital image processing, video compression, speech recognition, digital communications, radar, sonar, MIDI standards. This video explains the concept of musical instrument digital interface, that is MIDI. What is MIDI? MIDI stands for Musical Instrument Digital Interface. A MIDI is a communication protocol designed to allow instruments to communicate with one another. A MIDI file contains no sounds, just instructions describing the notes played in the performance and related information. The MIDI sound is played back through the hardware device or computer either through a synthesized audio sound or a waveform stored on a hardware device or computer. The standard MIDI file are Type 0, Type 1. Both variations contain the same data, but the arrangement of the data within the file is different. Type 0. Single track of data. All data is saved to a single track without regard to its MIDI channel reference. The file plays normally, but accessing the individual components is a bit more difficult. If editing is needed, the user can open the standard MIDI file in the application of choice and copy or paste individual channels of information manually as needed. Type 1. Multi-track of data. Standard MIDI file outputs a separate track for each MIDI channel in the original sequence. This format greatly simplifies the editing once the sequence has been transferred from one sequencer to another. MIDI ports. There are 3 5-pin ports on a typical MIDI unit for connecting a MIDI interface: in, out, through. The out port sends messages and it is connected to the in port of the MIDI keyboard. The in port receives incoming messages, so it is connected from the out port of the MIDI keyboard. The through port creates a daisy chain to connect more than 2 devices. The through port sends the messages that one device receives directly to the in port of another instrument. MIDI cable has 5 conductors. The cable is terminated on both ends with a Deuce industry norm DIN plug. Data passes through the cable on pins 1 and 3, and pin 2 is shielded and connected to a common ground. Pins 4 and 5 are not used. The length of the cable is limited. The IMA specification allows a maximum cable length of 50 feet. Multimedia and its components. In this video, we are going to see about multimedia and its components. Multimedia refers to a content that uses a combination of different content forms. It is the integration of multiple forms of content. Multimedia includes a combination of text, audio, still images, animation, video, or interactivity content forms. Audio. Audio can be used to enhance the interest and emotion to a presentation. It can convey meaning, providing an extra channel of information. Text. Text is used in titles, menus, navigation aids, and narrative or content. The text is the most widely used and flexible means of presenting information on screen. Images. Images in multimedia allows a user to convey ideas that they may have considerable trouble explaining in writing. Images can add visual interest to the presentation. Animation. Animation is a creation of artificial moving images to replicate an event. Animation helps viewers to understand a concept. Video. Videos are formed using a sequence of images. Videos are excellent for showing how things change or how something is done. Configuring multimedia components. Configuration of one of the multimedia components, that is VLC player, is shown in this section. If the setup file is saved in the computer, then locate them and double-click on one of them to begin installing. Allow the Install Shield wizard to initialize. Keep clicking the Next button until the ready to install the program window appears. Do not change the destination folder. When the ready to install the program window appears, click the install button. Click the finish button when the install shield wizard has completed. After the installation process is completed, configuration is done. Each of the component is configured in this way. Joystick. Now we are going to see about joystick. A joystick is an input device consisting of a stick that pivots on a base and reports its angle or direction of the device it is controlling. A joystick, also known as the control column, is the principal control device in the cockpit of many civilian and military aircraft, either as a center stick or side stick. It often has supplementary switches to control various aspects of the aircraft's flight. Joysticks are often used to control video games and usually have one or more push buttons whose state can also be read by the computer. Joysticks are also used for controlling machines such as cranes, trucks, underwater unmanned vehicles, wheelchairs, surveillance camera, and zero turning radius lawnmowers. Joystick elements: stick, base, trigger, extra buttons, auto fire switch, throttle, hat switch, suction cup. Working of joystick. In this video, we are going to learn about working of joystick. In order to communicate a full range of motion to the computer, a joystick needs to measure the stick's position on two axes, the x-axis left to right and the y-axis up and down. Just as in basic geometry, the x-y coordinates pinpoint the stick's position exactly. In the standard joystick design, the handle moves a narrow rod that sits in two rotatable slotted shafts. Tilting the stick forward and backward pivots a y-axis shaft from side to side. Tilting it left to right pivots the x-axis shaft. When you move the stick diagonally, it pivots both the shafts. Several springs center the stick when you let go out of it. To determine the location of the stick, the joystick control system simply monitors the position of each shaft. Components of joystick. In this video, we are going to see about the components of joystick. The various parts of the joystick are handle or top, stick or shaft cover or dust washer, pivot, base, mounting plate, spring, washer for spring, restrictor gate, wire harness, actuator, E-ring, stick or shaft, the rod in the joystick, handle or top, the held part at the top of the stick, which usually comes in two shapes, a ball top or teardrop or bat top. Pivot, the area in which the shaft swivels. A part surrounding the shaft is usually placed here to assist in this. It comes in shapes like cylinders and half spheres set on a plate that is contoured for smooth movement. Spring, the mechanism most joysticks use for automatically resettling the shaft to neutral. Some joysticks use magnets for this. Thicker or Larger springs make the reset stronger and movements more affected. A part is often added to secure the spring below the pivot. Actuator. The actuator gives the bottom of the shaft more area and precision in pressing the switches. The actuator can refer to a shaped enhancement surrounding the bottom of the shaft or the levers on levered micro switches. E-ring. An E-ring, also called E-clip, is a small, flat, curved plate of metal shaped like the letter E. It is a type of retaining ring, also called a circlip or snap ring, which is a type of fastener. It attaches to the bottom of the shaft, aligning and securing the parts along with it. This also puts some compression and tension in the spring, so the joystick has returned to a neutral position. It can be wedged off using a flat screwdriver or something similar and replaced using pliers. Another version is the C-ring. It pretty much needs to retain ring pliers, also called snap ring pliers, to remove and replace it. Other joysticks use a bolt or nut for the retaining function. Mounting plate. The plate of the joystick attached directly and securely to the control panel. Mounting plate and the dust washer are the only two parts of the joystick that need to touch the control panel. Guide or dust washer or disc or cover. With many times, this flat disc surrounds the shaft on top of the control panel to hide and protect the insides of the joystick and a hole in the panel. It also works to enhance play when part of the hand rests on it. Restrictor gate. A restrictor gate is a plate with a specifically shaped hole like a square or circle that determines physically where the joystick can be moved. It is generally attached to the bottom of the joystick, restricting the bottom of the shaft. Many joysticks do not come with restrictive gates and are always circularly restricted. Wire harness. Some joysticks have the micro switches attached to a PCB into which a wire harness or wires aligned along with a plug is inserted instead of having to wire each of the micro switches around the bottom of the joystick. Miscellaneous. Various joystick models and makers add various other parts to tweak and complete the joystick. They add things like screws, housing, extra spaces and scorers along with the shaft, other plates for holding things like micro switches and the pivot, and other pieces that tweak various components. Mouse. In this animation, we are going to learn about mouse. The mouse is an input device or control station for computers. The development of graphical user interfaces has made the computer mouse a standard input device. It is now practically available on any PC. The movement of the mouse run with the hand on the table or a suitable base such as a mouse pad is received via a sensor in the mouse, digitized and transmitted via an interface to the connected computer. The alternatives entail the operation of the computer using a trackball, a keyboard, a touch screen, or a tablet. The mouse was invented by Douglas Engelbart in 1964 and consisted of a wooden shell, circuit board, and two metal wheels that came into contact with the surface it was being used on. The first mouse, a bulky device, used two wheels perpendicular to each other. It was 8 years later, in 1972, that Bill English developed the design further by inventing what is known as ball mouse that we know today. The ball replaced the wheels and was capable of monitoring movement in any direction. The ball came into contact with two rollers that in turn spun wheels with graduations on them that could be turned into electrical pulses representing direction and speed. At the time, Bill English was working for Xerox PARC, Palo Alto Research Center, the research and development center set up by Xerox to design the future of computing. The mouse became part of the groundbreaking Xerox Alto computer system, which was the first mini computer system to offer a graphical user interface. An optical mouse was developed in around 1980, eliminating the ball, which often became dirty from rolling around the desktop, negatively affecting its operation. Today, the optical mouse has completely replaced the ball mouse, being supplied as standard with all new computers. Operation of mouse. In this video, we are going to learn about mouse. The mouse operation, that is function, is to help us to control the computer better and make it easy for us to access computer programs, documents, etc. The mouse is a pointing and clicking device. The pointing is simply the X and Y location plotted on the screen or display. Items on the screen have functions built into them, waiting for the mouse to interact with them. A click down on the button will start this process. Some web pages have JavaScript embedded in them to watch or listen for the mouse to move and click. The middle wheel of the mouse of today's computer mouse is designed to scroll and or zoom. Mouse is a pointing device which contains an optical sensor in its base. There are 5 basic computer mouse operations: left button, right button, scroll wheel, navigation control, connectivity. Single click to select the object. Double click to open the selected object. The left mouse button allows for the selection of and interaction with programs, internet web pages, and other computer functions. By clicking this button twice while hovering over program icons or double-clicking, the mouse instructs the computer to open the program. By hovering over an icon or other item and depressing the button once and holding it, the user can move or drag the item to a different location on the screen. In a text program, depressing this button and dragging it across individual words or entire lines of text highlights the selection, allowing for editing. The right mouse button is used for accessing specialized context-sensitive menu options for the particular program or screen button on which you click it. This allows you quick access to various actions without having to search for them in the toolbar at the top of the screen. If you click the right button on a text document, for instance, a menu appears allowing you to change the various properties within the document, such as the font style or size. Right-clicking on a web page allows you to save or print the page. Single-click only to select the icon. The pop-up window appears with its properties. Scroll wheel. Many computer mice are equipped with a scroll wheel nested between the right and left buttons, which allows you to move the screen up and down quickly. Normally, the mouse cursor stops as it comes to the top or bottom edge of a screen, requiring you to move to the scroll bar located on the right hand side of the screen to physically move the screen up or down using the left mouse button. The scroll wheel allows you to keep the mouse stationary and still move your cursor on the page. Navigation control. The bottom of the mouse offers the navigation control, which moves the cursor around the screen and allows you to select and interact with items. This navigation control is typically available in two styles, as a hard rubber trackball or an optical laser. Both perform the same action by recording the movement of the mouse as you slide it across your desk or mouse pad and transferring it to the cursor on the screen. Connectivity. Most computer mice connect to the computer via a cable that connects to the back of the tower. While this typically allows for quick and easy setup, the cable could become burdensome by snagging on objects or getting tangled with all other cables that computers require. To combat this, wireless mice are available, which use infrared signals to communicate with the computer. This allows user to complete motion and use of the mouse without the restrictive tendencies of a connected cable. Types of mouse. In this video, we are going to learn about the types of mouse. There are different types of computer mouse available, such as mechanical mouse, optical mouse, laser mouse, trackball mouse. Mechanical mouse. A mechanical mouse is a computer mouse that contains a metal or rubber ball on its underside. When the ball is rolled in any direction, sensors inside the mouse detects this motion and move the on-screen mouse pointer in the same direction. Optical mouse. An optical mouse is an advanced computer pointing device that uses a light-emitting diode, that is LED, an optical sensor and digital signal processing, that is DSP, in place of the traditional mouse ball and electromechanical transducer. Laser mouse. A laser mouse is a type of optical mouse that uses laser light to detect mouse movement. Like all optical mouse, the laser mouse has no moving parts inside. A laser is more accurate than the standard optical mouse design, providing for up to 20 times greater sensitivity and precision. The improved sensitivity and precision can be a key for gaming applications and graphical or engineering design applications where pinpoint accuracy is important. Trackball mouse. A trackball is a pointing device consisting of a ball held by a socket containing sensors to detect a rotation of the ball about two axes, like an upside-down mouse with an exposed protruding ball. The user rolls the ball with the thumb, fingers, or the palm of the hand to move a pointer.